So good morning, everyone, and thank you for joining us at the first Inspire20 session. I'm very happy to be here today. As Susan just said, I'm the technical assistant for innovation at the OGTC, and what we do in the Innovation Network is look at technology and society trends and try to understand how those can influence the future of the energy industry. So the energy transition is something that we're very active on right now. We'll start by looking at why an energy transition is necessary. So as a first question, and feel free to give your answers in the chat box. Has anyone seen this image before? Do you know what this represents, these stripes? And I'll give you a few seconds to put your answers in the chat box if you'd like. Okay, we have a no.
I've seen so many things online. I didn't know what it was, so it'll be interesting to hear your answer.
I see in the chat box we have some no's, some people are having some guesses, and I see some right answers as well. So these are called the warming stripes, and this is a representation of the temperature, the average temperature of the planet since pre-industrial times up until today, and every stripe represents 1 year. The blue stripes represent temperatures below the average of this whole period, and the red stripes represent the temperatures above the average. So with this picture, we can see that the temperature has been getting increasingly high, and we're in the last few years, we're getting some really hot temperatures, hotter than what was usual before. And why is this happening? How did this start? So for a long time, for maybe thousands of years, humans have learned how to use energy from their environment and turn it into useful things for their life. So things like fire for warmth and light, we learn how to harness energy and make it useful. But the Industrial Revolution, which started in the end of the 18th century, changed the way how we were using energy. It became much more intensive, and it also resulted in the release of emissions. So we're going to watch a quick movie that shows us how greenhouse gas emissions have been happening throughout these years, so the years that are represented in this picture, and that also shows us where they're coming from, so which countries are emitting. And I'll play that for you. At the same time, the energy industry hasn't just caused emissions, it's also caused a difference to people's lives. The more countries have industrialized, the more also living conditions have changed for the people in those countries, and they've been able to live in much better conditions. So let's have a look at this video first, which shows us carbon dioxide emissions. So it all started over here in the UK, and the little dots you see represent carbon dioxide emissions. The little bars will rise as the years pass, and you can see the geographical distribution of emissions, let's say. And along the bottom over here, we have a different graph that shows us how life expectancy changes as people get access to higher incomes. So at the beginning, most countries are standing in this area, and what we'll see is an evolution in the diagonal going upwards. As income rises, so does life expectancy and life conditions. And this is also portrayed in this picture over here. This picture on the right-hand side separates lifestyles into 4 levels based on 4 income levels, if we would separate it in that way. And the first level represents life in extreme poverty and with very limited access to resources, whereas the last level is closer to what we consider more comfortable conditions, having what most people in the UK would have access to: hot and cold water at home, varied meals, maybe being able to use a car for transport, and so on. Now, there's associated with the living conditions and with the access to income, there's another variable that comes into play, which is carbon emissions by income. So as people get access to more income and start to live a more carbon intensive lifestyle, the emissions peak very quickly. And you can see in this graph on the bottom how that's associated with each of the levels. So most people nowadays are living on the second level. They're able to provide for their basic needs, and they have a limited carbon footprint. But this hasn't always been this way. About 50 years ago, around 50% of the population was on level 1. So they lived in extreme poverty and had a very low carbon footprint. But the trend is that people will continue to improve their living conditions. The population will also grow, and this will really increase the energy demand. So we'll need to produce more energy to allow all of these people to be able to live better lives. But that comes with a lot more emissions if we continue to produce energy in the same way that we have so far. So that's exactly why we need an energy transition, and we need to learn how to produce energy more sustainably. And at which point are we now? So how's the state of the climate at the moment? On the left-hand side, you see two spirals that are growing at the moment. The top one shows the concentration of carbon dioxide in the atmosphere, and the bottom one relates the global temperatures to that increase. So you can see as carbon concentrations have increased in the atmosphere, so did temperatures in a very similar way. And this is the relationship of climate change. But now, at the moment, we are at 1 degree above the pre-industrial level. So with these stripes, we've already risen the temperature from here all the way to today. We've risen the temperature 1.1 degrees. The Paris Agreement in 2015 was a historic agreement where almost 200 countries agreed to address climate change. And the target is to keep the temperature rise below 2 degrees and make efforts to keep it below 1.5. So ideally, the efforts would allow us to prevent more damage to the planet and to the people that live on Earth as well, by limiting the temperature increase, which has very damaging consequences. Now, an increase of 2 degrees would have a lot more consequences than a degree of 1.5. So that would be ideally the goal we would strive for, would be to keep temperatures below 1.5. And what we see over here is a mitigation curve. The mitigation curve describes how much we need to reduce our greenhouse gas emissions in order to keep within the targets of the Paris Agreement. This one shows us how much we need to reduce if we want to remain below 2 degrees. And if we would start this year, in 2020, we would have to reduce emissions by about 60% year on year up until 2050. That would allow us to reach net zero by 2050, which is the target. If we would start later on, so if we would start 10 years from now, the challenge would be a lot bigger, and we would have to reduce 10% every year. So the later we start, the harder this challenge gets. And now let's look at the mitigation curve for 1.5 degrees. Now this is a much steeper curve, and this is a lot of a more challenging target. You can see that if we start mitigation into 2020, it's already very, very large mitigation rates are required. And that's the rate that we need to remove the greenhouse gases or stop our emissions. So it is very unlikely that this goal would be reached if we would continue with producing energy in the same way that we're doing now. And for that reason, it would be important to try to look at ways to remove carbon dioxide directly from the atmosphere to help us reach this goal. So who could we say drove this situation, or how did we get into a situation where we have a climate emergency? It would be easy to say that this is caused by the oil and gas companies and fossil fuel producers. What we have over here on the left is a picture from an article in The Guardian that describes the top 20 companies that have been responsible or that have contributed for over 1/3 of global emissions since the middle of the 60s. And these are all oil and gas companies. You will know some of the names over here, and it shows how much they've each contributed for this problem by producing the product to generate all these emissions. But at the same time, we can look at this problem from a different perspective. All fossil fuels and all energy sources, they are commodities. That means that they're produced because there is a demand. And that's what this picture here shows us. It's a bit complex, and there's lots of streams over here. But on the left, you have energy sources. And on the right, you have services or demand for those energy sources. And that's a bit of the approach that it's important to have towards this problem, because these products will be generated and extracted as long as we need to use them to maintain our livelihood. And for that reason, it's important that different departments of the economy, not just the energy producers, but other industries as well, look at their own emissions and do what they can to reduce their carbon footprint and help us sustain our lifestyles in a way that doesn't damage the planet. In this picture, we can see how much progress we've done. And the UK has already been able to reduce about 40% of their emissions. This graph shows us which industries have contributed to that. And we can see that it's largely been the power industry, so electricity generation and so on, the industrial sector as well, and a little bit on waste and buildings too. But there's much more that can be done. And all these industries need to work together to find ways to decarbonize their own activities. Now, you may have heard of the net zero targets. The UK government has established net zero targets for the whole of the country. So the United Kingdom will attempt to reach net zero by 2050, while Scotland will try to reach the same goal by 2045. And Wales will attempt to get to a 95% reduction of emissions by 2050 as well. But what does net zero exactly mean? What does this concept represent for the country? So to meet the targets of the Paris Agreement, it's predicted that we would need to stop emitting altogether by 2050, or to reach a net zero emissions by the year 2050. And what the net zero means is that we would reach a carbon balance. So it's not about not emitting altogether, because that wouldn't allow us to maintain our lifestyles, but it's about finding ways to, if we need to emit, then at least offset those emissions and making sure that the amount of greenhouse gases in the atmosphere stays constant, is not varying like it is at the moment. And there are two approaches to emissions reductions, or to attempt for a net zero economy. And the first one is mitigation. So we have to try to reduce the rate of emissions that we're sending. That's the first step, is emitting less. And that can be done in different ways. It can be through technology adoption, through changing the sources of energy that are being used, or the energy mix, or even by making specific lifestyle changes that will help us contribute to that goal. And then there's the sequestration, which is the other side, which is trying to find ways to capture more carbon, keep it on the earth or outside of the atmosphere before it reaches it. And that can be done by the natural ways, planting more trees, planting more peatlands, improving our natural sinks that also include the oceans. But we may not be able to do it at the rate we need just using our natural sinks. So we might also have to consider using carbon capture, capturing the carbon dioxide directly and trying to store it underground on the long term, either on old reservoirs or in aquifers where we're sure that it will stay for a long time and that we'll be able to store it safely and prevent it from warming the planet further. So how do we see this happening for the energy industry? How can an industry that has been so carbon intensive turn into an industry that's no longer producing emissions and damaging the ecosystems? At the moment, this is a representation of the current state of the North Sea, let's say. It won't be 100% accurate, but it's a picture depicting what it looks like last year, this year, at the moment. So we have a major basin. That means it's been explored for several years and production is decreasing slowly. There are several assets and several oil and gas assets and long and very extensive infrastructure, both through pipelines and platforms, different types of equipment that it's no longer being used as it has in the past. But this is an environment offshore, hard to reach, can be hazardous, and these equipments, after they're no longer used, they need to be either dismantled and removed, or repurpose. There's those two options. There are very high costs associated with the decommissioning. It's a very complex and hazardous process, but the way we see it is there's some opportunity for integration and for using these equipment in new ways. So the vision for the future of the industry is a much more integrated energy industry offshore that doesn't just have oil and gas platforms and a couple of wind farms here and there, but links those all together to maximize how much they can provide. And the way we see it, that will involve having an integrated industry that produces net zero emissions. That's a necessity. And where the renewables industry will be expanded significantly, the oil and gas production will be powered by renewables instead of gas turbines as today, which are pollutant. There will be carbon storage hubs as well to help us reduce the amount of carbon in the atmosphere, and those can be connected to industry clusters to help decarbonize industries. And at the same time, the hydrogen industry will be developed as a clean energy source as well. The way we see those evolving over time, and this is taken from the Committee on Climate Change's report, so those are their predictions, is that the oil and gas industry will slowly lose a bit of market share, and at the same time, the renewables industry, hydrogen production, and carbon capture and storage will all increase in market share, and they will reach more or less a balance. So all of them will have similar importances. And now on to technology. Technology is important in helping us reach all these goals, and it can help us accelerate all these changes. The image you see on the left, it's from the International Energy Agency and from their annual reports on the state of technology within the energy industry. And it tells us that clean technology progress is not on track. It's not where it should be yet. We have to accelerate it. And that's one of the focus areas at the Oil and Gas Technology Center as well. Some of the interesting technologies that we are looking at the moment and that we see being developed include these ones listed over here on the right, and I'll tell you a bit more about them. There's some focus on hydrogen transport, for example. Hydrogen transport is very challenging because hydrogen is a light gas and it's hard to compress. It's also hazardous because it can be explosive. And for that reason, we have two examples over here of liquid hydrogen organic carriers, which make the transport a little bit easier, and also ammonia for hydrogen transport, which allows you to transport ammonia and then put it through a membrane that removes the hydrogen and keeps the rest outside of it. And transport of ammonia is done every day. It's established and it's not such a challenge, so that would make it easier. Other examples are, for example, our carbon utilization. That's also another great way to prevent carbon emissions because we use the carbon dioxide as a product instead of a waste. And zero emission fuels can be produced in several ways. One example is using solar panels with a little circuit that allows for methanol production instead of just electricity. And methanol can be a fuel. So we will be taking carbon dioxide and turning it into a fuel to power transport or heat our homes. Electrochemical conversion is based on a similar principle, and it turns the greenhouse gases into a fuel or feedstock. And finally, direct air capture. And this is what we talked about when I said that we might need to remove carbon dioxide directly from the atmosphere. So if we need to do that, direct air capture is the way. It works almost like a big fan that pulls in the air, just simple air, and retains carbon dioxide and lets everything else flow through. So we would be retaining carbon dioxide, capturing directly from air, and then potentially storing it underground, reducing the composition of carbon dioxide in the atmosphere. Right. So here we see how the different countries in the world are progressing in comparison to their Paris Agreement pledges and goals. And it's the progress is so far in the largest side insufficient. So most countries have either insufficient progress or critically insufficient progress, which highlights the importance of collaboration. Climate change is a global challenge. It will affect all of us and every nation in different ways, but it navigates, so carbon dioxide can spread throughout the world through the atmosphere without us controlling it. And this shows us how important it is to address this challenge by working in collaboration and finding solutions that can help all the different countries, independently of their levels of development, to address it in coordination. And finally, if you've enjoyed this discussion and if these are topics that interest you, then a career in energy might be something that would motivate you and allow you to contribute to something that you're really passionate about. There are so many options. You'd probably be surprised by the different kinds of roles that you could take in an energy career. Mostly we would think that people would study engineering, or they would go to university and then move into a specific technical role, but there are so many options, and almost any background could really suit a career in energy. And the challenge is not a simple one to address. It will take complex solutions and well thought alternatives to help us address the challenge of climate change. So if this is something that motivates you, you should consider it independently of what your background has been so far. Now, I hope this gave you a nice overview of climate change, of the energy transition, and I'm really looking forward to your questions. Before we wrap up, I'll show you a few extra resources that you can have a look at if you would like to learn more about the topic. Those are over here. Oh, and these are sources for the presentation. So all the pictures that you've seen, if you'd like to see more, they're all over here. And these are a few books or online courses that you could take if you'd like to learn a little bit more. Thank you very much.
Oh, well done, Anna. That's an amazing feat to get all that information into 20 minutes. Fantastic. Thank you so much. I'm going to give our audience, I hope you enjoyed that, some time to pop some questions on the chat. Lewis, that question about the presentation, yes, you will be sent a copy of a PDF version of the presentation, and you'll also be able to see the whole video again afterwards. So just before we move on, Anna, I've got a question while everybody else is putting in their questions. I don't think people might, you gave such an in-depth explanation of everything there. I think people would be surprised that you are still at a very, very early stage in your career. Could you just maybe tell us a little bit about what you studied at university and how you got to where you are now? Maybe just a very, very short summary just to give people some insight.
Yes, so I guess the environmental side of this presentation is something I've been aware of since throughout my education, and it's always been a topic of interest. But while I was in school, I didn't expect that would be the area I would be working on. At university, I studied chemical engineering, and I was always very interested in the detail of how things work. But it was during a class of petroleum engineering that I learned more about the energy industry, the oil and gas industry in particular, and about the challenges that this industry has at the moment. So that's the moment when I realized that there's a lot that can be done in this area, and there are very interesting challenges that could make for a very satisfying career, or interesting and dynamic.
Absolutely. I think there's so much doom and gloom around just now, and people might not be thinking about careers in the energy sector. And I think this shows that actually there's loads of great innovation, exciting things happening, and great sense of purpose to actually be doing something to help our planet and our society. Okay, we've got a question here for you, Anna, and the question is from Charlene, and the question is, what has been the most interesting or influential tech discovery you've seen come through during your time at the OGTC to support the energy transition?
The most influential tech discovery. So that's an interesting question. When I first started at the OGTC, the perspective was very different. The energy industry was moving back from a period of downturn, especially the oil and gas industry, and there was a focus on maximizing economic recovery and on efficiency for operations. And over the last 2 years, it has really changed and moved into sustainability. I would say the key tech, I would say that has been the key driver of all of these technological developments that have come. But I think it was, yeah, definitely more of a mindset change than a single technology development that has made this situation take off. I would say carbon capture and storage will probably be a crucial technology for the future. We understand how it works, but it's still under development, the frameworks that will make everything go. But I would say that's a crucial one.
Great answer. Thank you. And I've got another couple of questions here. I should also point out that we've got Luca Caradi, who's our Innovation Network Director and worked closely with Anna. So if any of these questions you want to bring Luca in, please let us know, Anna. So the next one is from Martin. Which country is leading the way in reducing CO2 emissions?
Different countries are taking different approaches. The UK was one of the first ones to set the net zero target. At the same time, Norway is doing lots of projects on carbon capture and storage. They're definitely ahead in storing their carbon. Within Europe, there's also the biggest developments in wind energy, renewables. Several European countries are doing lots of work, but the United States, Canada, I would say globally, there's now a big push forward, and different countries are trying to find approaches to also decarbonize.
Which is really encouraging to hear, because we all need to work together on that for sure. Okay, here's another interesting one for you. You mentioned that this is from, apologies, I'm probably going to pronounce this horribly wrong, Ramandika. Oh, apologies. I can't even pronounce my children's name, so please don't be offended. So the question is, you mentioned that one of the solutions to reduce the amount of CO2 is by storing it in the ground. Do you think there will be an effect on the ground, the earth itself, either positive or negative, by doing this?
So this has been studied quite in depth. Carbon capture and storage. Geologists have for a long time tried to understand what would be the consequences. And so once carbon is stored underground, as long as there's a cap rock, it works as sort of a lid on the reservoir, the carbon will stay underground. And the longer it stays, it slowly modifies and turns into part of the rock. It integrates the rock through mineralization. So the carbon will slowly become part of the rock. In terms of the consequences of that, as far as I know, there aren't any security concerns in that area. But there are several institutes that are very knowledgeable about this, and the SCCS in Edinburgh would have a lot more information on this topic if you're interested in finding out more.
I hope that answered your question, but if you want any more information, if you want a link, if you get in touch with them, STEM, STEM at theogtc.com, and we can send you that link for sure. Okay, I think we're going to have one final question, and then we've got a fun question for you, Anna. So the next one is, there's two really good ones. I don't know which one to go for. I'm going to go for this one. It says, this is kind of bringing COVID-19. There is no escape. Do you think, this is from Kate Davis, do you think that the consequences of COVID-19 will have a major impact on the goal to reach net zero emissions? And if so, in what way?
That's a really good question. So the situation with COVID-19 has forced most countries to go into a total lockdown and to stop a lot of the economy parts, and that has had very negative consequences, definitely. But a surprising outcome was that we've seen an improvement in air quality in many big cities, and it's very encouraging to see how this has changed so quickly and how the environment has adapted so fast. But because emissions tend to stay in the atmosphere for such a long time, carbon dioxide emissions have a residence time of about 100 years. I wouldn't say the long-term effect would be very big. So definitely encouraging to see the adaptation capacity of natural environments. But I don't think in terms of emissions that we should think, okay, it's not as big of a problem as we thought. I think it shouldn't discourage us from doing as much as we can to reduce emissions anyway.
Absolutely. Great answer, Anna. Thank you. We've got some really good questions here, and I would love to continue, but I'm kind of mindful of everybody's time. if you would like to do more of this, we want to create a community for you. So if you've got ideas about how we can make this better for you, again, just drop me an email at stem@theogtc.com. It'll come to me, Susan, and I will answer it. And if we can do something more, we will. We certainly will, because we want to hear from you. We want to answer your questions. So Anna, are you ready for your fun question? Because this is the same one we're going to be asking all our speakers through Inspire20.
Definitely, I'm excited for the fun.
Yourself in 3 hashtags, what would they be?
3 hashtags to describe myself. Right. So I would use curious. I would say I'm very curious and always learning. I'm always trying to find out new things, or even outside of my work area. So I like to always be learning and to have different activities going on at the same time. I would maybe use also active or dynamic. I love to be outdoors. I love to do sports, and even at work, I like to feel like we're busy and that we're doing important and valuable work. So I like to be very, very active and dynamic. And I would say as well enthusiastic. So I mostly have a positive mindset, and I find all these changes quite encouraging as well. But yeah, I think those 3 might be a good description.
Fantastic. Thank you so much, Anna, and thank you for your presentation. It was great, and we can see from the feedback in the chat that people have enjoyed yourself. So thank you very much. Okay, before everybody goes, please don't leave the screen yet. There will be a survey coming up at the end, and we would really love it if you could just take a few minutes to fill it in so that we can make these sessions even better for the future. Here's just a few messages from me. There's a QR code here. So if you take your camera on your phone, and if you just click on that QR code, it will take you to the OGTC webpage where you can go and find out about more of the sessions. You can book in on them. The one next week, in 2 weeks' time, I should say, is on meta skills. And Milena, you asked a question about what skills would you recommend to master before graduation. What we've talked about a lot today is technical knowledge. I do people stuff, so I'm interviewing people all the time, and I can tell you that technical skills is great, but you also need to look at your meta skills. So if you want to know more about how you can really get a step ahead in terms of trying to find that new job, and what are meta skills and what are your meta skills, come and join us in 2 weeks when Skills Development Scotland will be sharing some more information about that. Last thing from me is, you can see there are 3 logos. There's so much information out there, and sometimes it can be quite overwhelming when you're either a young person trying to take that next step in your career, or you're a parent, or you're a teacher, and you're trying to signpost to get to the right information. So 3 things I would recommend you go for is, if you have a look at the My World of Work site, it's Skills Development Scotland, and they've got an area in there called the Hub. The link's on our webpage, and there's so much free learning. So if you've got some time, go and have a look in there. There's everything from edX, which is free courses from places like Harvard and Stanford and Yale University, right down to online courses from Microsoft, and they're all free. So go in there, access them, do it. If you're looking for more skills on interviewing, finding jobs, Life Skills by Barclays, a great website for teachers, parents, and young people. I use it a lot. It's absolutely fantastic. And the one in the middle, if you want to learn more about other careers within oil and gas and energy, have a look at myoilandgascareer.com. Great website. Last thing from me, we want to make this great for you. We want to create a sense of community. So if you want to do more with this, drop me an email at STEM, which is science, technology. I always forget the E. Anna, help me. What's the E again? Engineering and maths. I should know that one. At theogtc.com. I'm probably going to get sacked for forgetting that. Never mind. Thanks, Anna. Again, you did a fantastic session. Audience, thank you for joining us. It wouldn't be the same without you. Thank you all for taking the time to join us. And please stay online so that you can fill in the feedback. Thanks all very much. And I'm about to do my silly goodbye. Goodbye.
Thank you, Susan.
Me so that I don't look quite so silly. Bye.
Goodbye.
Bye, everybody.